So the paper that you got today is all about classifying triangles. Now, our book does not specifically go over classifying triangles because it's something that you guys have seen before. Classifying triangles by sides and by angles. So I'm going to go through the front part of the paper has some notes to it as well, so that if you forget something, you can refer back to it. So you should be on the side that says pages 5 and 6. All right. Now, this is your first assignment grade for the new quarter, so it's going to be due on Monday. If you look at the top part here, this first side is classifying triangles by angles. And there are 4 different ways that we can classify triangles by angles. You either have a triangle where all 3 angles are acute angles, meaning that they are angles that are less than 90 degrees. So, yeah, just going to write this off to the side. Acute angles are angles that are between 0 degrees and 90 degrees. Again, that's something that you should already hopefully be familiar with. We defined a right angle already earlier this year. Right angles are angles that are equal to 90. Obtuse angles are angles that are between 90 and 180. Oh, you can write all of that. Yeah. All right. So, again, obtuse angles are angles between 90 and 180. Now, so again, an acute triangle, all 3 angles are acute, meaning that they're between 0 and 90 degrees. For an equal angular triangle, all 3 angles of an acute triangle are congruent, so they are equiangular, meaning that they have equal angles. Right? Now, that means that since an equiangular triangle all has 60 degrees, again, by definition, it is also acute. Right? Obtuse triangles. One angle of a triangle has got to be obtuse. Right? The other 2 are going to be acute, right? But at least one angle is going to be obtuse. Could you have more than one obtuse angle in a triangle? No. We already learned that in a triangle you only have 180 degrees. So if one of the angles is more than 90, and you subtracted that from 180, you'd have less than 90 left over for the other 2 angles. So again, you can't have more than one obtuse angle. Same thing for a right angle. You can't have more than one right angle in a triangle. So for a right triangle, it is just that you have one right angle. So again, this is classifying triangles by angles. So on the examples here, this shows us that all 3 angles are congruent. So this would be an equal angular triangle. It's also an acute triangle. So again, this is both acute and equal angular. On the second example, we have all 3 angles. One of those angles is greater than 180, therefore it must be an obtuse triangle. And then for C, we have one of the angles is given to us as 90 degrees, therefore it must be a right triangle. Now, the other thing they could tell us, besides having an angle labeled as 90, is that you could have it marked as being a right angle or being perpendicular lines with our little symbol. All right? So again, if you have the symbol or you have that, you know it's a right triangle. Now, they also could leave out some angles because we've already gone over the idea of all the angles have to add up to 180. So if they only gave you, say, 2 angles, you could figure out the third and then say what it is. Now, on this side of the paper, they're all pretty much straightforward. So let's just do a couple. On number 1. Yes?
For example, C, I don't think that's right. How is it a right angle? There's no like...
There is a 90 degree.
90 degrees.
It says 90 degrees.
Oh.
Yeah, all right. So now, on number 1. Are all of them acute, or do we have a right angle or an obtuse angle in there? We have a right angle, therefore this is a right triangle. On number 2, it is obtuse, you're right, because this angle here is 120. That's an obtuse angle, so this would be an obtuse triangle. Number 3 would be an example of acute and equal angular. So again, you could do both here, because all of them are acute, but they're all also 60. So this would also be equal angular. Now, again, this is equal angular since we're defining it by angles. We're going to talk about equilateral in a minute. Equilateral is when all the sides are congruent. But no, anytime you have an equal angular triangle, it will also be equilateral. Later in the year, we'll talk about the relationship between the angles and their sides. There is a relationship between the angles and the opposite sides of a triangle. So, on number 4, all of these are acute. So this is just an acute triangle. So again, that would be those first 4 questions. Now you still have 2 more on that. You also have more on the back for doing this. Let's go on to the other half of the front, where it's talking about classifying by sides. So now, there are 3 ways to classify a triangle by sides. You either have a triangle, I'm going to read these in the opposite order for a second. So I'm going to start from the bottom. You either have a triangle where no 2 sides of the triangle are congruent. So that would be scalene. So none of the sides are equal. All right. So I'm going to draw a little picture right here of a scalene triangle. So this would be an example of a right scalene triangle because I gave it a right angle. Again, we can classify it 2 ways, but it's scalene because all 3 sides have different lengths. You have that short side, a little bit longer side, and then an even longer side. For isosceles, this is the one where usually the definition coming in is not quite perfect. So isosceles triangle. It isn't that the triangle has exactly 2 sides. Isosceles means that it has at least 2 congruent sides. So if I was to draw a triangle with 2 congruent sides, it'd be isosceles. Or if I was to draw a triangle that had all 3 sides congruent, it would also be isosceles. But now the one that has all 3 congruent is also known by another name. When you have all 3 sides congruent, it is equilateral. So any equilateral triangle also falls under the category of isosceles, just like any equal angular triangle falls under the category of acute. So again, there is some overlap in these names. So classifying these, this first triangle, and they tell us 2 sides are congruent, so it's isosceles. On the second one, you have all 3 sides are congruent, so it is equilateral, but also know that this one could also be classified as what? Isosceles, because it has at least 2 sides congruent. On C, the triangle has no pair of congruent sides, therefore it is scalene. So let's look at a couple on the exercise here. Number 1, we have 3 different lengths given to us. So what type of triangle is this going to be? Scalene. We have all 3 sides are the same. So this would be equilateral. Now, if it's equilateral, I can also call it isosceles. Because again, at least 2 of the sides are congruent. So I would like you to put both of those each time. Right? Because again, anytime you have an equilateral triangle, it has all 3 sides congruent. Isosceles means at least 2 sides are congruent. So every time you have equilateral, it's also isosceles. All right? And the reason why I stress that is because later on, we get into some of our theorems, and every theorem that we have for isosceles also works for equilateral. Go ahead. What's your question?
Oh, I didn't see that it was boxed up. I looked it up. It said two sides of the I don't understand why isosceles.
So again, the key word is at least. All right? And I know for the longest time, you guys have probably learned isosceles is two sides are congruent, two sides are congruent, two sides are congruent. But again, the key word there is at least two sides are congruent. So you can have all three be congruent and still call it isosceles. All right. All right. I want to do one more example there. So number 4. This one has two sides labeled as congruent, so that would be another way that you could identify that. This is isosceles. Now, I would like to do one of these algebra problems with you guys as well. So, if you know that two of your sides are congruent, and they don't tell you what the actual length is, but they give you some type of expression, you could then solve for either the variable or the entire length of the side. So on this first one, number 7 says find x and find the length of each side of RST in the equilateral triangle. So we have all three sides given to us. They told us it's equilateral. So since it's equilateral, all three of them are the same. So it doesn't matter which two we pick to set congruent. We should get the same answer no matter what. So I'd pick the two that look the easiest to set equal to each other. So I'm going to go with the 2x plus 2 and the 3x. 2x plus 2 equals 3x. Subtract off the 2x from both sides. And that leaves us with 2 equals x. So we already have half of our answer. We know what x is. But it also asks us to find the length of each side. So if we plug 2 in, we should find out that all the sides are the same length. 3 times 2 is 6. 2 times 2 is 4, plus 2 is 6. 5 times 2 is 10, minus 4 is 6. Now, if you wanted to write them out in terms of length, so like if you wanted to write them instead of labeling them, you could also write them out like this. Remember to use proper notation. So if we're talking about the length of RT, we don't put any segment over top because we're talking about the measure or the length of RT. Same thing with ST and RS. All right. So again, that's an algebra problem with this. So your assignment is to complete the rest of this paper. So there's a few left here on the front and then the entire back side. All right.